Yeah, welcome back to online class. Today we are going to discussing about skill enhancement course one. It is also belongs to the second year of a fourth semester. It's in skill enhancement course we have two courses. One it is remote sensing, GIS, and GPS, and second one it is geochemistry. Just we'll have a little discussion about remote sensing outlines. We'll see. Not going to very detail. You see their topics were mentioned here in a remote sensing. The first unit block remote sensing, and second block it is GIS and GPS. In a first block, again it's divided into the four units. From the four units, the first unit it is the introduction to the geoinformatics, remote sensing, the GIS and GPS. The second unit is remote sensing data acquisition platforms and sensors. Third unit is remote sensing data analysis. Fourth unit is the global positioning system. Coming to the second, that is the GIS and GPS. Unit fifth, it is speaking about the introduction to the GIS and its linkage to the remote sensing. Unit 6 is the GIS data products, spatial and attributed. Unit 7, spatial data measurements and analysis. Unit 8, integration of remote sensing GPS and applications. Yeah, next coming to the first unit, it's an introduction to the geoinformatics. It is an integration part of geoinformatics, that is the remote sensing, GIS, and GPS. We'll discuss the first the remote sensing, introduction of the remote sensing. What it is a remote sensing? It's a remote sensing. It is also arts and science. It's an art and science. It's giving the information a particular object or a particular about an object or phenomena without making or without taking of any physical contact with the same object. And that we see the contrast in site observation, or particularly it's a reference to the so that the remote sensing is speaking about particularly speaking about, or it's giving the information a particular object without any touching or without any physical contact of the same object, but we'll get the information by using of different methods. The remote sensing it is used for numerous fields, including to study of geography, to investigate the land survey, and the most of it science disciplines like hydrology, ecology, meteorology, oceanography, glaciology, and geology. It also has a military, and we can apply into the interior commercial economic and planning department, in particular, sense of humanitarian applications also. The remote sensing are used generally. It refers to the use of a satellite or aircraft-based whatever sensors which are mounted on bottom of platforms of remote or satellite or aircraft, and those are moved throughout the Earth surface and throughout the area, whatever target area we have fixed. Particularly in that area, it is rotating and scanning that area is taking the pictures. And based on these sensors, the detecting to classification of objects on Earth, it's including the surface and atmospheric oceans. And depend on this is depend on its working depend on the electromagnetic radiation, and it is going to be a switch in active remote sensing and passive remote sensing methods. And it is a reflection by the object that detected by the sensors. Or second one, it is a passive remote sensing. In the passive remote sensing, it is a reflection in the presence of a sunlight. Sunlight. So finally, based on these active and passive sensors, so active and passive sensors, we may observe, we may take the photographs. A particular definition, if you see the particular definition of this one, remote sensing, it is the science and art and obtaining the information about an object or area or a phenomenon. This data we will analyze of the acquired device, which is not a contact same object, and finally we'll get the information to investigate. The types of remote sensing. We see in general, there are two types of remote sensing we can able to identify. One, it is a passive sensor, and second one, it is a active remote sensing. In active sensors, which are having the own source of light or illumination, and its sensor is measured as a reflected energy. For example, a radar sat, it is illuminates a target and measures how much energy it is bounce to back to the sensor. Actually, it's similar to the flash camera you can able to see. Just example, for if you see your mobile also, if you wanted to take the photograph, then what we will get? Night time we will take on the flash, and we will take the photograph. That means it's a self-illuminated. The light it will be coming from the own machine, phone machine, or the light it is coming from your cell phone or your mobile phone. And then you are taking the photograph within a fraction of a second. Then what's happening? The light, whenever it is a fall on the object, that's absorbing, and at the time it is will be reflecting to the same area. So that in the reflection, the fraction of reflection will take the photograph. So it is a self-illuminated. It is a self-illuminated. Uh, and when you come into the passive sensor, in a passive sensor, it is a reverse pattern. It's a particularly it is a presence of a sunlight only, naturally. It's the presence of sunlight only, or a natural light wherever it is available, or whenever it is a light, the sunlight it is available, and then we will take the photograph. The example for this one, the Landsat, the Landsat means land satellite. 8, it is a measures the reflected energy emitted by the sun bouncing of the end. When the sun is releasing the energy on the earth surface, the sun is releasing energy on the earth surface, and then what is happening? The earth surface, it's absorbing the energy and it's emitting the energy. It's absorbing few objects, it's absorbing, and a few objects, it's after the absorption, it will be empty. Example for if you can see the plants, why they are looking into the plants in green color. In the presence of the sunlight, what is happening? In the plant's leaf, it has a chlorophyll. The chlorophyll property, what is that chlorophyll property? It is absorbing the green light, it's absorbing the green light, and at the same time, it is emitting the same light to outside. So that is the reason the plants looking into green color. So, so here it's absorbing, and at the same time, it is emitting. It's emptying the same. So that they, based on the source of energy, it will become some. It will become somewhere else, such as the sun or the lamp or whatever it is. Such. The passive remote sensing. In a passive remote sensing, uh, it measures reflected energy and emitted from the sun. So that it is reflecting the passive remote sensing measures reflecting the energy from the emitted of the sun. And active remote sensing, it is illuminates. It's a target and it's a measure. It's a black scan. The multispectral versus here the higher hyperspectral imager. In a passive remote sensing, we can be divided even further into multispectral and the hyperspectral. The main difference between the multispectral and the hyperspectral is the number of bands and how the narrow bands are narrow the bands are. Yeah, when coming to this is a multispectral imagery. It's generally it is refers to the 3 to 10 bands, 3 to 10 bands. Just you see here, uh, yeah, 3 to 10 bands. Days, 3 to 10 bands. The hyperspectral imagery is consisting of much of a narrower band, that's 10 to 20 nanometers. A hyperspectral image could have hundreds of thousands of bands. It's using an imaging spectrometer, using with a spectrometer. You can see here the bands it is showing. It's a microwave, infrared, visible, ultraviolet, X-rays. The visible range, it is a 3 OD, 1, 2, 3. It is indicating the visible range. The visible range maybe it is showing as 0.4 to 0.7. The three types of colors we can able to see. Those are blue, green, blue, green, 0.4 to 0.5 blue, 0.5 to 0.6 green, and 0.6 to 0.7, it is a red. As per these three visible ranges, the photos it will be, or the light it will be absorbing, and the light it is releasing from the sunlight, and it's a fall on object, and it will be, uh, or it will be released into the atmosphere. The remote sensing, it is the science and the art of obtaining information about objects or phenomena through an analysis of the data and acquired by a device which is not contact with the physical contact with an object. Yeah, the definition of remote sensing, it is restricted to the main of a process to acquiring information about any object without any physical contact and it in any way, regardless of whether the observer is immediately adjacent to the object or millions of miles away. It is a further it is a required that such sensing may be achieved in the absence of any matter in the intervening the space between the object and the observer. The information about any object or any phenomena it must be available in a form of that can be impressed on a carrier vacuum. Yes, most essential. The information, whatever it is, carrier, and it's related to the communication in the electromagnetic energy. The basic remote sensing data, it is basically it consists of a wavelength and its intensity information acquired by the collecting of electromagnetic radiation, and it's leaving the object at a specific wavelength and measuring the intensity. Yes, definitely. The remote sensing data, it basically is consisting of a wavelength, and the information it is acquiring, the collecting data, whatever we are collecting from the electromagnetic radiation, and it's leaving the object at a specific wavelength. It's a specific wavelength, and they're measuring depend on their intensity. A remote sensing of the environment, it's consisting and measuring the recording of an electromagnetic energy. The reflection, whatever energy, it will be emitted by the planets or surface or atmosphere from the vantage point of above the surface. The sensors which are mounted on aircraft or satellite platforms and measure the amounts of energy that it is reflecting from emitted by the surface or emitted by the objects whatever settled down on the surface. The measurements whatever we see, it's made into the very large number of points, and it's distributed um, which are distributed either in a one-dimensional profile or it's a ground below platforms or over into the uh, over to a two-dimensional area on their side of the ground pack of platform. Yeah, you see here the platform virtually the sensors, whatever it's in triangle shape you see here, the sensors which are moving. Then it's releasing the waves onto the surface. Yeah, the middle one it is indicating a satellite sub-satellite track, and the main the A and B, that's the distance between the whatever objects are there, and then the internal angle, that's another point it is showing another point it's showing, and then here the satellite is moving and it's scanning along the A and B. That means it's moving to the along the track of A and B, the between the center point. If we're taking the center point, along that center point, it is moving and moving. There, when the another point is looking, the ground area either side of the satellite or a platform it is image, whereas an area, whereas the area it's covering, whereas that area is covering by the satellite track, and it is imaged by the whatever sensor it is going to be covered. And the spatial patterns which are evident, the spatial patterns are evident in a remotely sensed images are interpreted in terms of a geographical variation in the nature of material forming the surface of the Earth. Such materials may be vegetation, exposed soil and the rock or water. These materials are not. These materials are not themselves detected directly by the remote sense. So what? Then the vegetations and other materials which are absorbing and releasing in different colors, and it's detecting by the remote sensing. And their nature is inferred from the measurements made. Broadly, it's two types of remote sensing systems recording information about any target of any area. They are one it is active and second one it is a passive remote sensing system. An active sensing system it is a generates the active generate system it is a generating and uses its own energy to illuminate the target and records the reflected energy, which carries the information, content, or entropy. The synthetic aperture radar is one of the best examples active active sensing systems, and these sensing systems operate in the microwave region of electromagnetic spectrum, and it includes the radiation with wavelength longer than the 1 millimeter. These systems do not rely on the detection of solar or terrestrial emission, as the solar irradiance in the microwave regions is negligible. So that here, the remote sensing systems which operates principles and general details of the latest imaging radar system, it can be describing. That means here whatever for images or whatever photographs what we are taking, we are using the two types of remote sensing systems. One, it is active remote sensing. It is a active remote sensing. It will be working in a artificial energy conditions. Or when you go into the remote sensing of passive remote sensing system, it compulsory it is a depend on must and should it is a depend on mainly on solar radiation operates. The nature and the properties of the target materials, which can be inferred from the incident of electromagnetic and where it is reflected and the place it's scattered or emitted by the earth materials, and it is recorded by the passive sensors. But there is no use of any flash camera or all those. That means directly if you are taking the photograph without any flashing camera. So in that, whatever available or whatever energy it will be there, and those it will be taking. The remote sensing system that uses electromagnetic energy and it can be termed electromagnetic remote sensing is different. Here, if you can use the remote sensing, if you can use the electromagnetic energy, in the taking of a photographs, you're taking the photograph, and that type of study it is called as a electromagnetic remote sensing. In electromagnetic remote sensing process, what it is that we see that in a particular, if you see the general process on the electromagnetic remote sensing, it's involved in as a passive active remote sensing. Namely, data acquisition and data analysis are outlined as per schematic diagram we see here. The data acquisition process is comprises some important elements. What are those? One is the first, it is depend on the electro energy sources, and second one it is the propagation of energy through the atmosphere, and third one is the energy interactions with the energy interactions with the Earth surface features, and fourth one is the airborne space, the spaceborne sensors, and to record the reflected energy. And fifth one is the generation of the sensor data in the use of the form of the pictures or digital information. These elements are described in next one chapter, but actually the first one it is energy resource. What it is the energy sources? What are the best energy resources? Actually, we have two types of energy resources. One it is natural. Second one it is artificial. And when you come into the natural means the sunrise will depend on the sunrise and the electromagnetic system. And coming to the next of that one, will we will depend on that artificial. The artificial maybe it is a artificial satellites. Those satellite sensors which is releasing energy onto the surface. And next one is energy interaction with the Earth surface features. Yes, energy it is interacting with the Earth surface. What are the Earth surface features? Maybe it's the plants, the buildings, the roads, networks, uh, water bodies, valleys, hills. So all the natural features, morphological features, whatever it is available on a surface, this all will be absorbing the energy, and at the same time, some of the elements, some of the objects have the capability to emit the same. In airborne, spaceborne sensors to record the reflected energy, vegetation, generation of sensors data in the form of the pictures. Yeah, here. Once the airborne or spaceborne sensors recorded the reflected energy, yes, definitely. Whatever energy it is released onto the surface, whatever energy it is released onto the surface, the released energy after that, again, the sensor is moving along the track, and the energy it is released on the surface of the different objects. Those objects will be pictured, or those objects will be scanned by these air bones sensors or satellite sensors. So that what will be happening. And it's taking the photograph. The observation means here the sensors which are taking the photograph. These sensors which are all the mounted Yes. Yeah, here the sensors, what about the sensors duty? Here the sensors, it's a recording, the reflecting energy, and it's taking the photographs, whatever uh, energy it's a fall, or whatever energy it's a fall on objects, and then in the presence of that energy, in the light energy, it will be taking the photograph or recording by the same. And the sensors data is releasing, or it's converting from the pictorial or digital information. Yes. The generation of sensors data is here. It will be stored in the form of the pictures, or it will be stored in the digital formation. And the data analysis is a progressive in the process which involves examining the data using the various viewing instruments to analyze the pictorial data. It's called as a visual image interpretation technique. Is here. After once it will be released the picture, then we will take that, we'll convert into the digital formation. Before the digital formation, just we see that is in a pictorial formation. The pictorial formation, it is called as here, the pictorial formation or the pictorial form, the picture form, it is called as here, the visual image. It is. And the visual image interpretation we do. That means we'll check the all the uh, pictures or in that pictures, all the objects, whether it is correctly printed on or whether it is correctly formed. We'll check it. We'll check, and then we'll check it to the ground reference also. This type of study it is called as a visual image interpretation. And then next step, we will use the different computers and to will analyze the data through the process. We'll analyze the data. That means once the visual image, the raw data, once we will converting into the different formats of the computers, whatever it is, it will be read, whatever it will be have a capability to read the computers, and in the format we will be convert the uh, image, we'll convert the image into that digital format, and then this study it is called as a digital image processing. It is called as a digital image processing, and the analysis of the data. It's utilizing the visual image interpretation. It is involves the use of it involves the uh, use of the fundamental features of the elements. What are those elements? We definitely have to know those elements: uh, tone, texture, pattern. Yeah, actually, it is a once if you converting into the digital, once if you converting into the digital, we need to study the some basic remote sensing elements. Those the basic remote sensing elements. One is the tone, uh, tone, texture, uh, pattern, size, and shape. And in order to detect the and identify the various objects. Suppose if you see the aerial photographs of that one. Yeah. Yeah. The aerial or satellite imagery, if you can see, suppose if it is a stereoscope instrument, we can uh, use to obtain the three-dimensional images. There are many photogrammetric instruments today. It's available to observation, but to identify the visual images, to interpret the data, and transferring the details onto the base map. Suppose if the data, if it is available on a digital form, we can have a chance to identify or analyze to interact with the computer system and to extracting the statistical data and to classification to obtain the thematic information about different resources. And then it is a interactively the analyzed using the computer by comparing the actual signature of the object. It is collected through through the field investigations. Maybe that the remote sensing, it is we know that it's making of measurements of if it's using of a sensor for aeroplanes or satellites, different satellites by the sensors which are collecting the data from different images, and it's provided by the special capabilities of manipulating or analyzing and visualizing the images. The remotely sensed imagery is then integrated within GIS. Yes, here integratedly we can use the GIS and remote sensing systems, particularly those uh, deployed in satellites. That means here the remote sensing system, particularly what we are using, we are getting the information from the satellites or from the airborne services, from the airborne servicing services, whatever data it is giving the information about target areas or about the features which are settled down on Earth. And also not only that one, we know that electromagnetic uh, electromagnetic spectrum band, the ranges which are the transmittable through the band length ranges in the Earth atmosphere, whatever it will be there, as per that it will be working. We know that our human eye, we can only detect the reflectance of the solar radiance. Actually, we can able to see the length range between the zero point 0.4 to 0.7 micrometer. But the remote sensing technology, it is allows or it is allowing the detection of other reflective and radiant energy like thermal energy. The energy band is ranges that reaches maybe or sometimes may be emitted by the Earth surface. For viewing the purposes red, green, and blue, the false color assignments also used to express the reflective quantities of objects with the in the electromagnetic band length. Yeah, here it is mentioned. You see that is the wave various regions are electromagnetic uh, spectral bands or spectral regions. It has mentioned here. You see that gamma ray. It is we know that 0.03 uh, less than it is a nanometer. And X-ray, it is from 0.03 to 3.0 nanometers. Ultraviolet, that is between 0.3 to 0.4 micrometers. And photographic UV band, that's 0.3 to 0.4 micrometers. Visible range, that is the no, that is a 0.4 to 0.7 micrometers. Here, the infrared rays also it is showing 0.7 to 1 micrometers. There, here it is interacting with a matter where is it a different wavelength and the atmosphere transmission windows are separated. The reflected IR band, here the reflected IR band that is maybe it's mentioning the 0.7 to 3 point micrometer. The thermal IR it is 3 to 5 micrometers of the band. Radar, radio and detect ranges, it is 0.1 to 30 centimeters. Again, you see here it was in 30 meters. And again, the radio waves, it's the longest and long wavelength portions of electromagnetic spectrum. It is from above the 30 centimeter. Here, these as per these wavelengths, as per these wavelengths in the electromagnetic spectrum, the energy it will be released into the surface, and different objects are whatever settle down on its surface, and those objects are absorbing, and some of the energy it is releasing to the or emptied into the surface. Some of the objects is directly it's reflected into the atmosphere. And what are the applications of remote sensing? Yeah, there are various applications. We see that the applications it's the radar is mostly associated with a aerial traffic control, and it's before warning and certain in the large scale meteorological data. And the Doppler radar it is used by the local law enforcement monitoring the speed of limits and enhanced meteorological collection, such as a wind speed and direction within a weather system. In addition, uh, to part precipitation, local and vocational intents. And by the measuring, second one it is by the measuring the bulges of water. It's caused by gravity, and they map features and the sea floor to a resolution of a mile. So, and another one it is ultrasounding. Ultrasounding is acoustic and radaring tide gauges. It's to measure the sea level, tides, and the waves directions in a coastal and offshore tide gauges. Another one it is LiDAR. In the LiDAR, light detection and ranging. It's also well-known example for weapon for ranging and the laser illuminated homing project light. LiDAR it is used to detect measuring the concentration and various chemicals in the atmosphere. Based on the light detecting the ranging as per that different light of the chemicals, whatever involved or whatever released into the atmosphere, the color it is for the color we can able to identify. The station remote sensing is the principal application of uh, LiDAR. The most common visible and the infrared sensors it's following by the microwave, gamma ray, and rarely ultraviolet. The spectropolarimetric imaging has been reported to be useful for target tracking purpose by researchers at the U.S. Army Research Laboratory, and they determine the man-made items and process the polarimetric signatures and where the natural objects are not found. And moreover, the Landsat images, which are used for regulatory agencies to indicating water quality parameters, including depth and chlorophyll density and the total phosphorus content, weather satellites which are used in meteorology and climatology. There are some hyper. Sorry for the interruption. Next, coming to the introduction to the geographical information, geographic information. In the geographical information, it's speaking about geography, and that is the information we cite with some specific set of locations on its surface, which including the zone of atmosphere, and its spatial is often used synonymously for our references. And the geographical in this context, although the principle might be taken into the information that is tied to the same other than the surface. But actually, today, the term of a geographical information system, we can apply it whenever we can apply it whenever the data it is in a digital form. Either where we will we wanted to add the data or we wanted to delete the data, external data. Whatever purpose for the manipulation, we have to definitely we'll use the GIS only. We'll use the GIS. Yeah, where we will use the GIS. The GIS it's using in the computer to make a map. It's with using of a GIS software and the same computer to analyze the geographical information and to make a future forecast using the complex models of geographical processes. The Earth images collected by remote sensing satellites or geographical data, whatever it is collecting by the different satellites, and which are all form of in the form of images. The GIS is tends to be reserved for systems that integrate remotely sensed data with other types or a process data that have already been clean and transferred. And similarly, an atmospheric scientist or oceanographer will tend associate GIS with the system. It's used more multidisciplinary work and policy studies. And the GIS it has the capability to interrelate especially multiple types of information assembled from the different sources. Many study and research models rely on the ability to analyze and extract information from images by using variety of computer available research tools and then express these feelings as part of a project or whatever layers we can see. And, and next, coming to the overview of information system. Yeah, GIS is providing the information about the object. It's one of the more fundamental issues which arises using digital information technology. What we wanted to examine on the surface or Earth or any related system, then we need the resource information system. That's for particularly in agriculture management, and it's considered as a multi-dimensional with attribute dimension or a spatial dimension or a temporal dimension. The geographical information system offers capabilities integrating the multi-sector or multi-level and multi-period database. The GIS is a computerized database system for capture, storage, retrieval, and analysis, display, and spatial data. It is a general purpose technology for handling geographic data in digital form, and it's satisfying the whatever specific need to us. The particular specific needs. The first one it is to ability to process the data, large stores into the suitable analysis, including the operations such as reformatting, change of a projection, resampling, or regeneration. and direct support for analysis and modeling. So that form of analysis, calibration, models, forecasting, and prediction, which all are handled through the JS structure. Uh, supposed to processing of a result, including such operations, reforming, tabulation, report generation, and mapping. In maximum all these operations, the typical GIS user now expects to be able to define the requirements and interact with the system with a user friendly. We see here as per our user needs. First, we have to do the planning, then data collection. Based on the planning, we need to do the data collection, and then the data should be stored in different formats, and again, and also from the different formats, again it should be have a capability to manipulate the data, uh, to analyze the data. After the data storage, then it should be manipulated or editing or edited, whatever. As for that, we'll go to the further. Next, it is a output product. In the output product, whatever required to us, whatever required to uh, user. As per that, we'll make the maps, or as per that, we'll make the data. Then finally, it is used for user action. It will be ready to use the data. And then finally, the result, it will become output. Okay, you need users, whatever users need. As per that, we'll make. And here, before MS, the next one, there are mainly four key activities that in urban planners of a scientist, or maybe it's a resource managers, the resource management system. Uh, they observe and measure the environmental parameters, and they develop the maps with a quarter characters of Earth system. In addition, they model alternatives of actions and the process operation environment. Uh, Four activities are important. One, it is measurement. Second one, it is mapping. Third one is monitoring. And finally, modeling. Modeling as a key activity. As for key activities, we should do all these things. The 4MS, from the 4MS, it is important in examination to become right about 4MS. 4MS means here measurement, mapping, monitoring, and modeling. 4. Measuring, mapping, monitoring, modeling. Yeah, you see here. Here the 4MS is explained. The first one, it is the measuring. In a measuring property, in particularly whatever map we have, it should have a scale. According to that, the scaling we will get the measurement. We will get the measurement, and then that is maybe land use or land cover cadastral, like whatever maps for whatever maps we are getting, or whatever maps we are going to study. As per that, we'll as per that we will take in consideration that should be measured. The area it should be measured. It has a scale. And second one, it is the mapping. According to that measurement, or according to that scaling, we are ready to the map. We are ready to make a mapping. And next one, it is the monitor. In monitoring,
We see the objects. What are the objects which are located, and what are the components are there? What are the objects that are having? Either maybe it's related to the environmental system, or it's related to the um, drainage network system, or it is related to the um, related to the terrain model. These are all we need to observe, and then finally we'll go for the modeling. In a modeling, as per our requirement, we'll do the model. As per our requirement, we'll do the modeling. Most of the GIS is containing analytical uh, capabilities for reclassifying the overlaying maps. Any GIS system, if you see the any GIS for measurement of the areas, distance, angles. For that purpose, it's required two components. One, it is standard measurement unit, and second one, it is a measurement process. As per this, as per this, we will classify, or we will give the names to them. There are some contributions and disciplines. Here, the GIS, it is a useful technological field in all the sections, in all the disciplines. Yeah, GIS, it has been called an enabling technology because of that, so the potential it offers for the a wide variety of a discipline dealing with a wide variety of a discipline dealing with the spatial data. It is related to the many fields, and it's providing the many techniques with using of with making a GIS. You see here the GIS is related to geography, cartography, CAD, and computer the software, automated cartography, and it's also associated with stats and mathematics, and it's related to the surveying study, photogrammetrical study, digital photogrammetric study, and finally it is close associated with remote sensing technology. Yeah, the component of GS we'll see in the next class tomorrow. Just tomorrow also we'll see the GPS, and we'll again tomorrow we have a to see the we have to see the geochemistry also. That is another skill enhancement course. I'm stopping here. Thank you.